بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. الحمد لله الذي علم بالقلم علم الإنسان ولم يعلم. نحمده ونشكره سبحانه وتعالى. Thank you for attending our seminar today, and thank Migdam actually for organizing this series of seminars and keeping us alive actually with these interactions and lectures. Okay, this is a seminar on a project regarding some sort of small project that we started last year, and it started producing some results during the past year, and it is a proposed actually theme project for Midland. And for many years now, people have been using actually what we call Corpus Linguistics to build very useful applications in the area of NLP. And regarding actually English and other languages, so many corpora have been established over the past few years for various purposes. Actually, this includes the Brown corpus. As examples, the British National Corpus, BMC, and maybe the most famous one now, heavily utilized, is the University of Pennsylvania VBank, which is a very rich corpus and multilingual. It has a version, a Latin version for English, and it has an Arabic version as well for Arabic people. And I will go very quickly actually through the major points regarding actually the project and the achievements that have been done so far. Okay. And start by a small analogy actually. If you have been working with compilers of programming languages, usually people writing compilers know very well actually the language is quite deterministic. The syntax is predefined and checked for ambiguity actually. And the lexical part again is finite. You cannot invent your words in a programming language. You have to use the keywords provided by the language, unless you are using variable names. So everything is deterministic. That makes life very easy. You'll be able to write the compiler and concentrate just on the code and the design of the compiler and how it works. But when it comes to natural language, imagine that you are trying to program the computer using natural Arabic or natural English. In that case, actually, the compiler writer will be in a mess. He cannot follow you, actually. He cannot actually detect your syntax or semantics or even the vocabulary. It will not be easy interactive in that case. So this is the situation. A natural language is ambiguous. Ambiguity is everywhere. There is ambiguity at the lexical level. There is ambiguity at the syntax level. There is ambiguity at the semantic level. So everywhere you get things actually very ambiguous. But why are we keen? I mean, why do we care about natural language if we are using the computer? And the answer is well known now. If you are using, for example, Siri on Apple or other speech recognition program, you know that natural language is well actually on its way actually to interaction with computers. So natural language may be spoken and may be written actually, but people currently concentrate on the written part. And there are many applications actually for creating natural language, not actually for interaction with the computer directly. For example, spelling correction. Spelling correction in documents is a very well-known application where we use actually the techniques that I'm going to describe today. Machine translation is another example where we need actually to treat the language at low level. We need to parse, we need to look at the lexical components and the structural components of a document. And so many examples actually, many information retrieval, of course, and text mining, which is again social network mining again. Okay, so all these applications actually require some sort of deep treatment of the language, being Arabic or English or any other language. Okay. So there is a very well-known field, as you know, statistical computation. There is a field called computational linguistics, of course, you know that, of course. And there are many courses offered in universities, either in the context of languages or in the context of computer science. It is a joint area. And if you remember, actually, in the Women's College, actually, we established a very interesting program that is now actually freezing, or now actually it's a POS in computational linguistics. It has so many courses on morphology and syntax, semantics, everything that's related to this. So this is a very interesting field which is rising now and being applied actually real life now. Many companies now actually are considering actual natural language as a major player in the market in the very near future. And a subfield in that area is called Corpus Linguistics. And this is an empirical field where we use statistics collected from a text or a speech corpus in order actually to simplify or to solve problems currently in the area of human-computer interaction or other related fields of it. And based on that, actually, as you may have seen actually in many universities and in many companies, actually, people started building corpora. A corpus actually is just a collection of text or spoken language actually collected and processed actually for the purpose of collecting statistics regarding the context of a given word, for example, or the context of a given sentence. So roughly, a corpus actually may be considered actually as an entity or a tool that may be used actually to facilitate actually some work in other fields of it. Regarding Arabic, there have been many attempts to build corpora, annotated corpora or tagged corpora in order to facilitate again work in this field. And the most famous one again currently, or the most serious and practical one, is the one built by University of Pennsylvania. The tree banker I talked about this a moment ago, and Leeds University also. They have a very serious goal in this field. Another university, Lancaster University in the UK as well, for building some sort of minimum corpus. Also in the Middle East here, there are so many corpora now, but most of them are not annotated. For example, Caxt. They have a couple of corpora, Arabic corpora, one for their own use inside Caxt, and the other one actually is public. I think about 12 million words, but not annotated.
Are you talking about the Norway?
I'm not sure about the official word, but they have one. They told us actually in our meeting with them that is public for everybody to use, and there is another one much larger that they are using actually inside Caxt itself. And I gather actually both of them are not tagged yet. At least the public one is not tagged. So if you are looking for a tagged corpus, currently maybe the only official one is the University of Pennsylvania, Legal. It's available, but a little bit expensive. You have to subscribe. And there are other problems, of course, when I talk about the details of tagging regarding this corpora. Okay. When we say a tagged corpus or unannotated corpus, we mean so many levels actually of tagging. The easiest of them, or the most straightforward, is the low-level one, which is morphological tagging and part of speech tagging. They are related to each other, maybe the same actually, with a slight difference regarding the tag set. And when we, just to explain what we mean by tagging or annotation, identifying actually the meaning of tagging or the major purpose of tagging is to identify the lexical category of the word and maybe sometimes the syntactic role. So for example, noun, verb is a major category, for example, particle is a major category, and inside noun, of course, there are so many subcategories. And also for verb, we know, for example, in Arabic, imperfective, perfect, and usive. All these are actually classes of verbs. So the major purpose of a tagger or an annotation program is to identify clearly, actually, without ambiguity, the class or the type of word. And above that, actually, there is what we call syntactic tagging, or what we call the tree bank, in which actually we create structures on top of the corpus, used actually again for training. Most of this information is either used for solving problems or training an application that will solve that problem. Now, a good example is spelling checker. Okay. In spelling checking, actually, we use a corpus to train the spelling checker, or giving information. We'll speak about the process of training in a moment. Okay. So in that respect, actually, the tree bank will be used actually again to give information, maybe for parcels or high-level applications. Semantic tagging, another level where we use actually to collect semantic tags or annotations for given words. How this is done actually in many applications actually the tagging or the annotation is inserted in the corpus itself. So with every word in the corpus, we associate a tag or a type that really shows actually the type of the word or the class of the word. Then other programs will work on this text to collect or to compute statistics, for example, unigram frequencies or bigram frequencies in order to use this actually in resolving ambiguity in some applications. Just the previous slide, let's say something. So the most popular, now one use of the easiest one, publicly used in many corpora is the part of speech tag. Part of speech means again the type of word in the context of a document, for example, is it a word, is it a verb, and that of course depends again on the use in the document. For example, certain words actually the same spelling may be used actually as a verb, or sometimes as a noun, or sometimes, for example, the word ba'd in Arabic. It may be ba'da, it may be ba'd, and so forth. Okay, so you get different. This is why part of speech tagging is because in context the type may differ from one context to another. Okay, so the major purpose of the tagger in this case actually is to parse or to go through the document word by word and give a decision. What is the category of this word? And again, because this is not a programming language, the task is very difficult because you have to decide based on the context. So it is not a trivial task, and it requires a lot of work, and lots of approaches are being used actually. And in order, again, to create a tag corpus, you have to start with a tag set. So you should have a tagging algorithm, and this tagging algorithm will work on a tag set. Okay. So based on the tag set, you tag the corpus. So you should start, for example, for English, for example, the Brown corpus, I gather, let me remember, about 79 tags. 79 tags in the tag set. For BNC, the British Noun corpus, about 61 tags for the corpus. Okay. For Penn, the University of Pennsylvania, the tag set is only 45, I guess, for English. So choosing the taxes is not a trivial task or agreeing. And interestingly, actually, all these people do not agree on. For example, for English, there are so many organizations working on corpora, and there is no common tax set. Not only, even the number of tax in the taxes is not agreed upon. So this is one of the big problems actually, and should be researched actually. And for Arabic, the same problem. For Arabic, the problem is even worse because people are just starting, and most of the people working on this corpora actually are usually Arabic for them is just a second language, or even not a second language. They are just specialized in natural language processing, and they are interested in the future. For example, they recruit actually people from speaking Arabic to help them with the work, but taking the decisions regarding the tax set and the nature of processing again is a little bit more. There are so many collections of tax sets, and also there are many approaches. And the approaches here I'm putting actually on the slide figure actually 4 major categories of approaches. For the easiest one is hand coding using some sort of rules. And the hand coding usually is started by a simple frequency program that will blindly assign a tag to each word. Based on collected frequencies. For example, we know for Arabic, there are certain categories that are already researched, and if the word is an oscillation, we can give you, for example, if you give the word, for example, the word I talked about, Baghdad or Ba'd, depending on the statistics, we give it the highest frequency. Will it occur very frequently as a particle or as a noun or as a verb? Okay. So based on that, we roughly give it that based on the highest unigram frequency. So this is the first part. And they say for English, for example, in many cases this gives 90% accuracy. This is very interesting. For Arabic, there are no statistics on that. Okay. So based on this initial assignment of tags, using sort of linguistic space actually, we walk through the documents again, which is a very tedious process, as you may imagine, in order to correct the tags based on the context. Usually this is not done for large corpora, it's used for sub-part of the corpus in order to train the algorithm later on. Okay. And in other cases, we apply rules, a sort of if statements, like express systems, to assign actually based on the context. If the previous word, for example, is ila, and the second word is a noun, then this should be so you write actually rules that will work on windows of the documents, from one window to another, until actually you correct most of the tags in this case. The stochastic approach is the most popular approach currently, and they use hidden Markov models, and right there the algorithm in particular is very popular now in these areas. And also they use some sort of variation of Bayes likelihood formula in order to actually, again, using either using bigram or trigram frequencies for the corpus. Okay. And a third approach, transformation-based approach. A famous example is also called the grid dagger. Again, this is a learning algorithm that learns actually some transformation rules from a given trained corpus. So we assume that there is a trained corpus, and through that trained corpus actually we try to learn some transformation rules that may be applied to a new document dynamically. Now the most important feature here actually to note is that most of these algorithms can work after being trained. They can automatically annotate a corpus, and this is actually the major goal. We train an algorithm, we create an algorithm, we train it, and then we give it a corpus. This will simplify the task actually, and there are so many algorithms actually that are working either for Arabic and for English. The accuracy of which is actually like 97% or in the 90s. So the problem actually have been solved for certain languages, but it's still not accurate 100%. Machine learning, of course, neural networks and other approaches are also used in this case. Okay. This is an example of an HMM approach used to resolve actually the tags or the annotation for a simple sentence. I want to race. And the keyword here, actually, they call this example very frequently because of the word race. It may be a noun, it may be a verb here. So in order to, if you are scanning the corpus, then when you come across this sentence, actually they use a sort of hidden Markov, a variation of hidden Markov models actually, and they collect actually, these models use bigram probabilities or bigram frequencies. Now, what do we mean by a bigram frequency? It is a sort of frequency of two words. I mean, associated with each other. For example, to rest. Okay? How many times to appears before rest? Okay? This is a bigram frequency. For example, I want. How many times I comes before one or one comes after I? So it's like a table. We collect frequencies for each word separately. For example, want, rest. We collect the statistics related to them actually in isolation. These are unigram frequencies. And then associated with bigram frequency, which give an idea about the context. In this case, actually, both of them are fed to the model. And as you can see, there is a chain of calculations that are propagated. This is by the algorithm actually, from the beginning actually of the net until we reach actually the final calculations. All through, of course, we compute certain statistics and scores, and depending on the last score, we decide is race, is a verb or a noun. Okay. So, and this is a very high level, and then takes a full actually presentation to explain by verb alone, or even some sort of exercises not critical. Okay. This is my idea about the taxes I just mentioned. So Brown Corpus 87, not 79. It's 79, I guess. Okay. 61 and 45 for 10. Now for Arabic, let us look at this is actual U pen, and this gives you an idea actually about the sort of tags, and this is the actual notation used in documents. So you will, if you look at the tag corpus, you will see the word /cc, for example, /nn, /md. So always you have to have this document with you in order to decrypt actually the meaning of these tags, and this is another problem actually, the tags in most cases, and the symbols used again for these tags are not very standard. Everybody uses his own symbols. So if you are tagging corpus, you have to provide them. And of course, these are the 45 tags. And for English, this may be enough, but for Arabic, certainly the situation is clearly very different. Now, the project actually started, we collected actually, or organized a corpus consisting actually of four, let us say 500,000 words, Arabic words, in 14 categories, including economics, religion, arts, and many fields. From some of it from the web, some of it from newspapers, some of it from books. So this is how people go around actually. And by the way, also there is a problem. They call it a corpus because it is not in use actually. So I think you have to get permissions, or you have to buy it sometimes. This it's not easy actually to collect the corpus like that and use it publicly. So there are certain actually regulations and rules that we should follow, and maybe some sort of legalization is required. But the good news actually, there are so many newspapers around. Upon request, they may give you actually.
So this is in Arabic or?
In Arabic. Now the work done in Arabic.
What about the tax set that you use?
Yes, it's coming. This is the situation. It's okay. I'm trying to describe in detail actually the work done. Okay. And we divide it into two components. One component is for training component that is annotated. before we apply our, and the purpose of the training here is to train the tagging algorithm. As I said, actually, the major purpose of this exercise is to train the tagging algorithm so that it can work on its own later on. Because, for example, if you are tagging a sort of, imagine that 10 million words or 12 million words as a tags, for example. How many people do you need who can tag this manually or who can work or can check its security test actually? So the availability of a trained algorithm is very important. An algorithm that will work with high accuracy, about 97% of the time, let us say, the target, or maybe close to 99 sometimes, and it's feasible, okay. Now, the answer to this
Selection of the pieces. It's like is it random?
Yes, random, yeah, based on availability again, because this is just a prototype project, and it's not a very serious work. We just wanted to explore the situation. So we collected with to make sure that actually we have something that we can work on our own. Some people actually use it. Al-Hayat, for example, newspaper, they have a large corpus that can be provided. Cracks now actually maybe the easiest way to crack their public one to use it for this purpose. But it should be comprehensive and should cover all aspects of concurrent language. I can easily actually take all the old books now given a certain, and that will be just one domain. Okay, so you need to cover. And some people actually talk about even contemporary language, which I do not support a lot. I don't want to encourage actually contemporary local dialects because this is counterproductive actually in our case. We just want to stick to at least the minimum that we agree upon in all the languages. Okay. Now the answer to your question is on the tax set. It's a very big tax set actually. We discussed it a lot actually with some people, and we looked at the publications of people working on Arabic actually. Therefore, for your information actually, very interesting actually. There is a very good group working in Columbia University in New York, and the most famous figure there is Dr. Mazar Habash, and their publications are very sound actually and very good. And in Leeds actually there is a group led by Eric Atwell, who is a British interested in Arabic, and they are producing quite good work actually. One production of the work actually is tagging the Quran, the full Quran actually, and not only tagging and the tagging is very interesting and very nice in XML format, and also they create a sort of dependency trees for the full Quran, okay? And also they have so many actual pieces of work, and also in Lancaster, one of the initial publications came from there. There is a lady called Hoja, I forgot her Shane Hoja, which produced actually the first serious tag set for Arabic. Okay? Now we came to the conclusion after reviewing the work of these people and looking at other, that actually Arabic cannot actually, it's not feasible to use just a limited tag set like English. For example, even the 200 tag set used by Hoja is not enough actually. And it seems that at the same time actually Nazar Habash and his colleagues reached the same conclusion. And Leeds people also, it seems that at the same time they reached the same conclusion. So we decided to go for a very wide tag set. And that tag set, will, rather than call it part of speech tagging, we call it morphological tagging. And our tag set is simply the whole set of morphological patterns for Arabic. Very interesting, of course, a big degree. Now, in the set we used, actually collected about 1361 morphological patterns. And if you click on the hyperlink, in this addition to the closed sets, the particles, the pronouns, which is a limited set, okay? So the dark set is huge, but very useful. So this is what have been collected so far, and most of the تفعيلية بالعربي. Okay? The morphological terms. They are finite, of course, in Arabic. This is about all of them, by the way. You can hardly find more, but you can differ. Of course, as you can see here, there is a problem with this. The critics are not there. This is one problem. The other problem is that, because clearly there is ambiguity. Because, for example, if you look فيعلم, in the second line, actually, it has 3 forms, actually. And each of them actually indicates a different category, or a different lexical or morphological category. But the most interesting part about it is that you can clearly identify the part of the speech tag at granular level, very deep. For example, if you look at فعل الاسم معرب مفرد مذكر ثلاثي مزيد بالياء معتل العين, and so much detail, and even the semantics can be added regarding this in certain circumstances, of course, when you go to the semantic phase, okay. So the part of the speech tags will be a byproduct. This is part of the set of products we have seen here, okay. And we decided to overload it. So a prerequisite for the tagging process is to build a database for these tags themselves and annotate them themselves. So they should be annotated before annotating the corpus. And this is they are pointers. So the صيغة التفعيلية in our pattern is a key to another table that will give you not only the part of the speech tag, it can go as far as adding the diacritics. تشكيل ما موجود طبعا. عرف التشكيل العربي is absent. So a major requirement in many Arabic applications is to add it. For example, in speech to text applications, also text to speech synthesis. Speech synthesis, a major problem we face actually in speech synthesis is that the diacritics are not there. So in order to produce the word, you have to know the الكلمة. So this is a byproduct for this process. If we use this tag set, automatically actually we'll be able, as we are going to see using Viterbi, to deduce not only the part of the speech, but also the diacritics, the inner diacritics, of course, of the word. The inner diacritics, of course, we need the structural syntax, and that is another issue. So it is a big jump, actually, a brave, a brave task, actually, to attempt, because it's very large, secondly, compared to 45 to 3 bank, and 61. Of course, this adds to the complexity of the process and the algorithms. You can imagine the data structures now and how to prepare, and even the sparsity of this okay. So the process we have actually, we have also morphological analyzer based on an algorithm. We coordinate this one sort of asynchronous matching algorithm. And it has been published, by the way, and has been in use for some time, this one specifically for this morphological analysis. And it has been very successful, by the way, in preparing the training corpus, because we started by preparing the training component. And for that purpose, we used SWAM. And we trained the SWAM, we collected, and SWAM works at the morphological level. It means that it can segment the word itself in order to decide the type of the word, okay? Or in order to deduce the morphological, and we thank actually Naif for working on the C# version of the algorithm. It has been written initially in modern language, okay? And in the initial phase, we asked about 3 linguists to work with the program on the corpus. Okay, so in order to collect the initial data, so they just confirm the algorithm work is very fine. Sometimes it misses, but SWAM actually is a comprehensive algorithm that gives you a list of possible solutions, possible, let us say, tags. So the linguist clicks on the correct one, and if there is no correct one, he said not applicable. That will be okay. So initially we prepared the small part of the corpuses, the swan diagram, morphological diagram, and then that have been corrected by using inner diagram frequencies. For example, we collected usually in an Arabic word there is the raclytics that are associated with the word, either preclytics or proclytics, which are part of the word itself. So in order to decompose the word, you need a morphological analyzer. So we collected actually statistics on these clitics. For example, the prefix. For example, how many times they can, for example, the most extreme example, here there is a prefix here, which is part of the word. So we collect frequencies on the stem. How many times does it come after this prefix? And also the suffix, how many times does it come after this? And that actually helped us to disambiguate actually the work of the swan itself. Then after that, of course, we used the corpus to collect the training corpus to compute or to unigram and bigram frequencies. And these statistics have been used to train an HMM model to produce a working tagging algorithm. Now the accuracy of this algorithm is currently 92 on the testing that we did, but 92 for 1,400 tags is a big achievement, because I can achieve easily 97 for a small tag set like 45 for 9 but using more than 1,000 tags and achieving 92 is a good sign actually, but we are not satisfied with the accuracy yet. And inshallah, more work is needed actually to train the algorithm. If you click on the sample one of the algorithm, yes, you are not expected to read everything, but this is sample one for the Vitega algorithm based on the diagram and frequencies. And maybe the column that we need to look at is the most left column, the scores. These are the scores. This column. This is where the scores come in actually. As you can see here, we score. We try to score as much as possible the possibilities. As you can see here, each word has so many possibilities, it repeats. And there are so many possibilities. So we try different solutions. What is the pattern related to this word? Most of them are wrong, but only one or two are correct. So based on this actually, and based on the score, we pick the right pattern, and we associate, and of course we store it in our tag corpus. So each word will be tagged actually by the appropriate, or the most appropriate tag in this case, based on the score of the algorithm. And that applies actually to opticians. If you can go back to the other example, that is, these are some examples for which actually short sentences, for which actually you already decide the solution is there. Unfortunately, instead of using actually the column, the numbers, you see for me it is on the left, or maybe on the numerical column. This is actually the tag, but cryptic as you can see, because we are using numerics at this stage. It's not mature yet, okay? But the explanations are here, okay? So it gives you actually, of course, these answers are not 100% correct, but they give you actually at least, they recognize actually the tag for the word, and all that details comes as a byproduct, okay? So it's not only just the tag, but all the information regarding the details of the word. That's more than enough actually for any application to use or to apply to. Now, of course, this is the status of the system currently, actually. So we faced so many problems. A major problem actually that's very common in this field, unknown words, because when you assume always that when you are moving to a particular word, you rely in order to determine the type on the previous word or the word after it, and then the score for that. If the word is unknown, then the score is 0 in that case. So that will propagate. The 0 will propagate, there are multiplications as you can see, and that will cause anomalies. So there are so many solutions for this. Some people start with assigning non-zero values for these unknown words uniformly. Some people actually, so the number of these unknown words is not trivial in our case because we have a very sparse structure, especially in the beginning of it. The critics, of course, are not there. The structures are very sparse with many zeros. Of course, the tag set is just this is an initial annotation, as you can see, and we need a sort of professional annotation for the tag set itself in order to make it more useful, and sometimes also deduce an abbreviated type of word based on the description, so that we can rely on it. What is it at that stage of it? And okay, and of course the semantics are coming. We will use semantics at the same level of this tag set. So we'll associate some sort of, and semantics are very important, especially our colleagues working on social networks. They know a big problem there is word sense disambiguation, because you get words and you want to relate them to some sort of sense, which is missing now in many applications. Now this will be a byproduct actually of this comprehensive action. And now the raw data actually, and this is actually just a plan, because this is done off-site, as you can see, and off Migdan, and outside actually the framework. Now we want to, our plan actually is to host it in Migdan as a major project, and it is open for participation. Anybody who can contribute, because this is a big, huge actually task that will go for some time. And this time we want to make it, of course, in a very disciplined way, so that actually we want to put the name of PSU with other, at least at the level of the other universities like University of Penn and University of Leeds and University of Lancaster, at least, and Columbia as well. And we want to start actually with it. So let's go to the, this is the previous one. Yeah, yeah. So now the corpus. We need actually, on this corpus actually is just a toy corpus that we work with, only 500,000 words. And we didn't use a very systematic way to connect it, because we just connected it for just to try our system. But we need now to do it in a very systematic way. So in order to collect the corpus itself, we need to read about how there are so many articles published regarding how to build the corpus and how to organize it. Okay, so we need to do it in a very proper way that will cover actually. So this is the first task, and of course after that reprocess the corpus, and then this is like cleansing in normal data mining application, just making sure that everything is proper. Maybe using certain tools, and maybe using certain experts in the field, and of course the classification. And of course we need a corpus management system to make it dynamic. We don't want a closed corpus, we want a corpus that will grow with time, and we want to add to it actually. So our corpus management system is a must in this case. Okay. And of course we need to design, tokenization is not a big problem, but there are certain issues we need to decide upon in the beginning, for example. Because Arabic orthography, there are so many odd things. So you need to treat them. How do we deal with this actually when they arise? But it's not a very serious problem, but it needs to be documented and mentioned as well. Of course, yes, also we need to develop, of course it will be used actually for developing other applications in order to test actually our work. It's not done for the sake of a purpose. Of course, we need to revise the current tag set and discuss it in detail. And shall we go with this big one, or shall we aggregate it? By the way, these people, their tag set is not less than ours. The same concept, if you look. It's included here, but they have the same approach. But they use feature vectors rather than using tables like ours, of course, in this case. They use very cryptic characters. They use about, they overload the morphological patterns, actually all the features with so many features in a vector, character by character. So we need to discuss this, and we need to come to a conclusion regarding the tag set and how to. And once we do that, actually, we need to create actually a database for the tag set itself and annotate it and make it actually. So this is actually. And of course the games will be quite big It's a very badly needed actually tool, and we should actually work seriously on it. Thank you. I'm sorry, my battery is a little bit low.
And the three points.
That's okay. So, first of all, actually, it's an invitation. Maybe already invited Saleh and Ahmed, maybe later on Naif, and of course, all of you. And yes, of course, as well. I guess Arabic is not very far from Urdu.
Yeah.
So I think we should concentrate and we should push it, and we should organize actually regular meetings regarding this and try to pick it up day by day. So we'll initiate it now, but the major purpose of this now is to initiate actually the work regarding. Unfortunately, resources, some of these resources are already available. For example, we have a little bit of servers, and also we. If it is a big actually corpus, then a cloud-based solution may be interesting for all researchers, not only in the university, but from other universities as well. And again, later on, we may need to take certain decisions, but after we proceed, and we delay the other decisions regarding actually the dissemination and the participation from our side. That is a different issue. But this certainly would be a good asset, and it is a missing brick in KSA. And if we do it properly, it will actually give a very good reputation for the university, and it will be better certainly than the corpus built in Western universities, and more feasible. So quality is very important in this way.
Thank you for the presentation. I have two different questions. The first, I am familiar with the schema. And so, if you can explain to me what is the exact difference between that? It seems to be the same goal, but different way.
Well, there are big differences actually. First of all, stemming is a Latin terminology. In Arabic, we call it morphological analysis because morphology is different from. So a stemmer, as the word implies, sort of a word level, lexical level analysis, actually morphological level analysis, because lexical we consider the whole word as an entity. In morphology, we segment the word. So it segments the word, and because Latin languages, or specifically English, concatenation in the sense that actually, for example, most of the words we just are ed or I-O-N at the end, so there is, stemming is easy. We just analyze the word and we segment it. You can take, for example, the stem, which is the basic word, for example, like, let us say, live, and then if we say lived, there is a D, so the stem will be able to retrieve actually the stem of the word. And in Arabic, actually, the situation is slightly different because Arabic actually words are based on a root, not a stem. And interestingly, actually, most of Arabic dictionaries are organized. You cannot actually use an Arabic dictionary using just the word itself, like English. You have to look for the root. For example, if you are looking for the word on mubsirun, you cannot use the keyword mubsirun as such. You have to look for the material ba, sa, ra. And it's not written as a full word if you look at the whole dictionaries. So in Arabic, the morphological analyzer, although many words may behave like English, where there is a stem and there are prefix or suffix, in many cases actually there is sort of like a chemical transaction. For the word actually, when it's generated, as you can see, sometimes you lose or you omit certain words, and sometimes actually, so the situation basically is root centered in Arabic, and that is what we call a morphological analyzer. So SWAM here is a morphological analyzer that we mentioned here.
I mean, those who understand that the Arabic stomach, they did this. Shireen, I think she brings the word fruits.
Yes,
So
but they use, even there is a guy called Buck Walter who is American. Now they use the word stemmer for sometimes wrongly for the morphological analyzer. Also not the stemmer, okay? But they use a morphological analyzer. But tagging need not use a morphological analyzer. This is another tagging is the approaches that I have shown here. You may skip the morphological analyzer altogether. Because you need tokenization in this case, taking away. And then based on tokenization, you try to use statistics, or like the Whitehead algorithm, in order to decide what is the tag of that word. Is it a noun? Depend again on the level of tagging. If you are just looking for general tagging types, then in this case actually, maybe just a simple tag like for example, brick tagger or without morphological analysis can actually give you the tags. But in many cases, morphological analyzer greatly simplifies the process of tagging and aids a lot. So tagging, morphological or stemming may be used actually to help in the process, but it is not a must, in my opinion. So again, the big difference actually, stemmers and morphological analyzers usually by nature are ambiguous. They give you many answers, many possibilities. Okay. While a tagger is supposed to give you a clear, unique solution for each word. So ambiguity is not there. The tag should be. So the tagger naturally disambiguates. There are so many other requests actually when we use this one. It gives you so many solutions because the segmentation may be different. And there are so many examples that we put in this paper.
I have a question regarding the corpus that you are planning to extend into order on corpus. Are you planning to make use of currently available Article Barbara? I know that in the past they are aiming to achieve 1 billion mark person that Barbara. Another friend of mine, Algerian, has his own Barbara around 700,000 words or so. So, do you plan to make use of available Barbara?
There is an advantage of building a robot, and there is a disadvantage. But the advantage is that you will build it properly, because we don't know how these people did build their program and how they represent what is the status of this program. But cats, I guess, they are doing some sort of proper work, and we already mentioned it to them in our meetings, if you remember, when they came here, and they told us they have this public control, but it was not annotated. So it is a possibility to negotiate with them after looking actually at the nature of the corpus. It's available publicly, we don't think there is no barrier or we don't have to subscribe, but we have to take the permission for using it, okay? So we're looking for possibilities.
Another question regarding when you talked about the wide grounds, as we know that the end grounds in general may refer to words, letters, or other parts of I think you are focusing on word lexicon. Is there any significance of considering the depth of level of
depends on your application. For this may be relevant to OCR, for example. OCR, because the character information sometimes they get noisy characters, and using the frequency at the character level may resolve this problem. Also in SWAM we use it not at the character level but at the segment level, the morpheme level. Usually an Arab project may consist of up to 3 segments, prefix, stem and suffix. Okay. And in that case it has been very useful actually in resolving the ambiguity at the morphological level. So yes, it can be used. And our additions and questions. But what do you think about the project? Is it a good idea, or we just shall we scratch it, or?
I think